Hi everyone, my name is Jaison Mathew. In this video, I'm going to show you how to configure high availability on Cisco Wireless LAN controller using GUI. In one of my previous video, I covered how to configure HA using configuration wizard. So this time I'll show you how to configure that through GUI. In this scenario, I have two 5520s for showing you how to configure the HA. So as you can see here, this redundancy section is not available in the monitor page, and I will show you the redundancy configuration on my controller side. So as you can see here, my redundancy basic configurations are already done to save some time, and I selected this one as a primary one, and the SSO is not enabled yet. So before we go into the redundancy configuration, we have to make sure some of the dependencies are taken care in the background. So first thing is you should have a valid management interface IP address and valid VLAN ID. Because without VLAN ID, you will not be able to proceed with HASSO enabling because it's a mandatory to have VLAN ID from 8.2 onwards. Then a redundancy management IP will be configured using the same VLAN identifier from the management interface. The next one what we need is redundancy port connectivity. So this port should be connected directly to the secondary controller, and that particular IP range will be starting, it's an auto IP starting from the controller side, and it will be taking the last digits from your redundancy management interface configured on your controller. So let me show you the same thing on the controller side in CLI. So let me log into the controller. So as you can see here is this SSO is disabled, and peer status is not available, not applicable or not available. So because it's not configured yet. So let's see how this one is going to react to the configuration on the other side. Okay, so in global configuration, this particular IP, I put a dummy IP. So let me show you the configuration on the secondary side. So here I have redundancy management IP as 13, but I given the redundancy management IP as 100 here. So let me change that to 13 first. Then next one is SSO. I have to enable that SSO here. Then next thing is how to configure your service port for the peer router. So using this configuration, what we can do is the service port interface IP can be provided from the primary controller, so that in case of a failure on the controller side, the primary controller hardware failure or something, you can use that service port from the secondary side. Otherwise, service port configuration is it's an individual one, because if you can't use the service port IP address from the primary in the secondary controller. So in case of a failover scenario, you have to use the service port on the secondary controller to access that device, access that particular hardware. Basically, you are sharing your IP address and host name in your network. So service port is the only one you can use it for the connectivity. But when HA is up and running, the service port will not be available using GUI, but you can always do the SSH and see the statistics on the controller side. But a GUI will be available only if that secondary is active. So now I made the mandatory changes here. As you can see here, I changed this to enable state, and this IP address editing part is already disabled. So let me apply this first. This one is applied, then I'll change that to enable. Otherwise, this IP address change, maybe it will not get affected. So this is the configuration I have to make on the primary side. A valid IP address and redundancy unit should be primary. Then enable HSO. Then click apply. When you do this, this one is going to reboot the controller. So as you can see that here, this controller already got that request and it's rebooting. So now let me do the same stuff on the secondary controller. So as you can see here, this IP address is everything is correct, and the secondary is also correct. Only thing is this SSO is not enabled. So let me enable SSO here so that this particular hardware can reboot with HASSO configuration enabled. So both the devices, both the WLCs got the instruction from GUI saying that your HASSO is going to get enabled, and a reboot is a must for getting that HASSO running in background. So this reboot, we have a lot of reboots involved in HA pairing. So first thing is, if you are having a hardware failure or something, or the secondary is coming up in your okay, so first time I shown you that a secondary controller is booting up and the primary is not available. So the initial stage, the first time secondary controller is going to look for the configuration through the XML validation section. So what will happen in a factory default settings, it will come, it will boot and you will get the configuration wizard. Then after that it will go for HA pairing. So in configuration wizard, before configuration wizard, there is an XML validation session. So the first time controller will boot with the default configuration and XML file will be selected in that, and it will come and come to your configuration wizard part. So whenever you go through that wizard and you configure the HA parameters, it's going to reboot, saving the config. So it saved the configuration in XML format and it rebooted, the secondary controller rebooted. Then it will reach to a stage that you are loading that controller using the XML configuration saved in background, saved in the flash. Then it booted and it will reach to the state that secondary is looking for the primary controller. So in that particular stage, it will realize that there is a config difference between primary and secondary, and it will do a bulk sync. When you do this bulk sync, you have to go for one more reboot to make sure the XML file in the configuration side is selected in the right manner, because there is an XML file change happen in the configuration saved in flash. So that time controller will again reboot and that will come back as a secondary and it will join with your controller without any issues. But here let's see who is going to come up first. If primary didn't come up first, or primary couldn't find the secondary between that time frame of 120 seconds, the secondary will not be able to come and join back as a standby controller, because there is a, as I said, everything should be in an order. If that order breaks, we will end up in having a rebooting scenario. So here you can see that XML configuration selected. The same way you can see that XML configuration is selected on the secondary side. So right now primary is trying to load the config from your XML stored in flash. So basically whatever you have in the clear text, it's getting saved as an XML file in background in flash, and that is getting converted using an XML validation method. So that validation will be done and it will be saved as XML config file. As you can see here, XML file config selected. So this is the one I was referring to. Because right now this secondary controller don't have the bulk sync done in background, but they already selected an XML validation file. So now both are rebooting. So there will be a stage, okay, so primary is searching for primary. So primary got connected. Here also you got connected with the primary. So as you can see here, the primary selection started here. So starting redundancy, primary is selected, then negotiation message is sent to your peer, then found the peer and starting the role determination and everything. So basically the primary and secondary was already configured and it avoided one more reboot. So that's why I'm saying this sequence should be same, otherwise you are not going to have a straightforward one because you have to go for multiple reboots. Okay, so now both the controllers are in sync. Show redundancy. So as you can see here, peer local state is active, peer state is active, and you got your primary up and running and secondary up and running in HA mode. So even the license got secondary got the license from the primary controller. Then bulk sync status is completed. So basically the HA configuration with SSO enabled, that is done through GUI. Now let me go to the controller GUI of 5522, and as you can see here, this is not available. But in primary, you can still access your controller using the service port, and secondary it's not available. So for that, you have to make sure your redundancy, you have the valid IP on service port here, because this IP address is populated from the other side, and you have to add peer network roots here. So if you have peer network roots, then only that particular peer will have that information, and it will be able to serve the service port, because your gateway information will not be passed to your service port interface. It's an IP, it's an interface that is having only IP and subnet mask. Gateway will not be configured there. So that you have to configure on through this peer network routes. In monitor page, now you can see this tab is coming into picture, redundancy tab. So when we start this video, it was not available, and statistics will show you the basic stuffs. So when I click all, you can see these are the statistics from the primary and secondary, and from the redundancy part. Then peer statistics, it will show all the statistics from peer. So CPU usage or process memory, you can go through the available stuffs. Then next one is summary. This is the summary, whatever you seen in the CLI, the same will be displayed here, most of the items. Then detail one, it will show you how this one is working in background, and how keep alive messages are transferred between controllers. So this is how you configure your Cisco wireless LAN controllers using GUI for high availability. Hope this one will help you in configuring the HA in your production scenarios. So thank you for watching.